Welcome to my channel. Today we want to look at the scalar triple product and the vector triple product. That is, if you're given three vectors, can we get the scalar triple product and the vector triple product? So we go straight to the example, and the example is, if vector A is this 2, 4, 4, vector B is negative 4, 4, 7, and vector C is 2, 3, 1, can we find this? So this is what we're calling the scalar triple product. This one, the scalar triple product. And this, where you have the cross, is what we call the vector triple product. This is the vector triple product. So those are the two things we want to see how to obtain in today's video. So we'll go straight to the answers. And there are various ways of doing this, but we'll be looking at the easier ones. So of course, you know that if I was to get this is a dot, this is C dot. There's a bracket here, and then A cross B. So for us to do this, one of the ways of doing this would be, first of all, to get the cross product, A cross B, which we know how to do. And then there's the answer that you get. Now find the dot product. Supposing that D is A cross B. So what we now do after we've gotten D, now find the dot C dot D. Find C dot D, and that will give you the solution to this. That is one way. But the other way is the way of finding the determinant of these three vectors. Find the determinant of these three vectors. So that is, if I have 2, 4, 4, and negative 4, 4, 7, and that is 2, 3, 1. Can I find the determinant of this matrix? And so the determinant of this matrix will give me the same solution as this. So this is the method I'll be using. But you can also use this, where first of all you find a D by getting the cross product. And then the solution that you get, find the dot product of C with that solution. But I'll stick to this method. So let's go straight to the solutions. So I began by defining them. I began by saying that C dot A cross B is the scalar triple product, or some books call it the box product. And as I've said, we will calculate it the same way we do calculate the determinant of matrices. So this is C, I have C1, C2, C3. And then this is A, A1, A2, A3. And this is B, B1, B2, B3. And the coefficients of A1, C were this, and this was for A, and this was for B. So we find the determinant. And there are various ways of finding the determinant of matrix, and you know them. But I'll choose this easier one, where I write the matrix here. And you can see this is the matrix. I've just transferred it here. And these two columns, I've added them here. So what I now do is that I realize that there are three diagonals in blue here. These three diagonals that run from the top left to bottom right, I'll multiply along them as I add the results. So for instance, 2 times 4 will be 8, times 7 will be 56. And then 3 times 4 would be 12. Then times negative 4 would be negative 48. And then 1 times 2 times 4 would be 8. These are the diagonals in red running from top right to bottom left. I will multiply along these diagonals and subtract the results. For instance, 7 times 2 is 14 times 3, that is 42. So I subtract 42. And then these are the diagonal. This is 4 times 4 is 16 times 2, 32. So I subtract 32. Then lastly, there's this diagonal, which gives me negative 16. So when I subtract negative 16, what I get is positive 16. So working out all this, I get negative 42. So negative 42 is the scalar triple product. This. So this is negative 42. So we want to get the vector triple product. The vector triple product, this is what we want to do. So again, as you see, it's easier to work out this one. Although there's another way, and I'll show you the other way, but it's easier to work out this. Find A cross B. Let's say that A cross B gives you D. And if it gives you D, then come and find C cross D. And this is what will give you C cross A cross B. This gives you that. That's what we will do. And just to mention before we go far is that the use of brackets in finding the vector triple product is very important. And this bracket is very important. But for this scalar triple product, you can do this bracket. You can do a bracket and you still have to get the same result. But for this vector triple product, if you did away with the bracket, you will not get the same results. And the reason is because we know that cross product is not commutative, but the dot product is. So let's go straight to obtaining this. Let's go to where I did my work. So I used this method, and there's another method I will show you that I used. I began by defining this, and I said this is known as the vector triple product, and it's calculated as follows. So first of all, I did the cross of this, and this ijk. We already now define the cross product because we've been doing it in our previous videos. So this will be A1, A2, A3, and then B1, B2, B3. But we know these are the coefficients of A. And so the coefficient of A was 2, 4, 4. And that of B was negative 4, 4, 7. So when we do the cross products, I take the whole of this matrix and insert it here. And then take these two columns and add them here. And then I have these diagonals. Multiply along these diagonals and add the result. Multiply this along these other diagonals and subtract the results. We already know how to do that. And so that gives me A cross B remains. So once I have A cross B as this, I now want to come and find C cross this. So that is in my next step. C cross that. That's what I've written here. I said now find C cross that. So I know what C is, and I now know what D is. So if D is this, and the question had already given me C, I now want to find the C cross this D. So that will be ijk, c1, c2, c3, d1, d2, d3. And I write the coefficient i's, jk, write the coefficients of c, and then the coefficients of d. This one's 2, 12, negative 30, 24. And then carry the whole of this matrix here. And then the first two columns, add them here. And then multiply along the diagonals in blue as I add the results. And multiply along the diagonals in red as I subtract the results. So doing that gives me this vector triple product as this. So that is the answer. That is how we get vector triple products. But I say there are other ways. So I want to look at the other way of doing that. And that's what I've written here as alternative method. So I've said alternatively, if I'm given C cross A cross B, then this can be given by, and look at what I've done. I've taken C dot this last vector B, C dot B, then times A, times the first vector here, and then subtract. Now we come and have C dot the first vector A, C dot A, and the result that I get multiplied by vector B. So this is multiplication, actually. This is multiplication. So it's very easy. And once you get to know the format, it becomes very easy. That I have this last vector. I begin by that, C dot this last vector. The result that I get multiplied by the first vector. And then subtract. Now C dot the first vector. And the result that I get multiplied by this furthest vector. So let's just do that. C dot B. We had the C. So we had the C. C was this 2, 3, 1. And the B was negative 4, 4, 7. So the dot product will be 2 times negative 4, which gives me negative 8. 3 times 4, which gives me 12. And then 1 times 7, which gives me 7. So the whole of this will be 11. What about C dot A? So what about this C dot A? C dot A, this was C, and this is A. So doing this dot product, I get 20. So now I come to my formula. And this is the formula. C dot B times vector A. C dot B is 11. But this is vector A. And then minus 20, which is our C dot A, times vector B. This is vector B. So when you do that, you notice that this would be 11 times 2I will give you 22I. 22I. And this is negative 20 times negative 4I, which gives you positive 80I. So this gives you 1 or 2I. What about this other one? This will be 44J. 44J. What about this? This will be negative 20 times 4J. It gives you negative 80J. So these together, they give you negative 36J. Similarly, if you worked for K's, you would get 96K negative. So this is the other way of finding the vector triple products. That's it, the other way. Let's look at some points from what we've already done. So from this example, we discover the following. Part 1, we discover that if I'm given the the vector triple product, this vector triple product. And then the easier way for me to work it out would be A dot C times B. So A dot the farthest vector times this other vector minus now A dot B times C. We've seen in from our previous example. What about if I have it this way? So if I have it this way, again, I'll do the same thing. The farthest, this one and this, I get their dot products. And the result, I multiply by vector B. Now come back and take now this B dot C. And the result multiplied by vector A. So this will give me this vector triple product. And this will give me this vector triple product. What you notice that these two are not equal. They're not equal. They're not, you cannot say that this and this are equal. They're not. And that's what I've written here. Meaning that these two are not commutative. So let's look at an example here. And the example says that let alpha be this vector and beta be this and u be that. Find this. And we've already done it. We've already done a similar example. And then we have to do this. And then we have to do this. But this one I've left it to the learner as exercise. So I'll do this using the same method of find the determinant. So I'll be finding the determinant of the coefficients of these vectors. And what you notice that these ones are commuted here. Even if you remove the bracket, you get the same result. And you notice that they also obey commutativity. But this one will not obey commutativity. So let's see how I did this again. So just as in the previous example, what I did was I found the determinant of the coefficients of these vectors, alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, mu 1, mu 2, mu 3. And the coefficients of alpha are this, coefficients of beta are this, and those of mu are this. So I find the determinant using the simplest way. I find the determinant of this matrix. So I took all of this matrix, put it here, and the first two columns I put it down. Multiplying along these diagonals and adding the results. Then I also multiply along these other diagonals in the red and subtract the result. This is what I got, negative 61. So this gives me negative 61. You can go through the multiplication. This is just 16. This is just 21, and so on. So the multiplications are here. So you can try that later. What about this? So I want to use the easier method. And just a minute. The easier method for this is where I get this dot this. Then the answer I multiply by alpha. Then minus this dot alpha. And the answer multiplied by beta. So that's what I did. So what is the dot product of mu and beta? This is our mu, and this is our beta. So I get the dot product there. Then minus, then multiply by alpha. This is alpha. This is alpha. And then minus, this minus is here. Then mu dot alpha. This is mu dot alpha. The result multiplied by beta. So let's just do that. Let's just do that. What I know is that the dot product, I have this 1, negative 1 times negative 4, which gives me 4. I have this 3 times negative 4, which gives me negative 12. And I have this negative 2 times this 7, which gives me negative 14. So the dot product here, this would give me negative 8, and the total would be negative 22. Because this is 26, yes, negative 26 plus 4, which is negative 22. So this negative 22, I multiplied by this alpha. When you multiply negative 22 by alpha, what you get will be negative 44i, negative 44i, and this will be positive 66j, and this will be, is it 110? Negative 110k. So that's what I get. Then I come to this other vector here. Find the dot product again. There's this negative 1 times this 2. That gives me, and remember is this negative, but let's work out this first. So negative 1 dot 2, that gives you negative 2. 3 and negative 3, that gives you negative 9. Negative 2 and positive 5, that gives us negative 10. And then we have this 4i negative, 4i, that is 4j, and plus 7k. So what is in this bracket? This is 21. This is 21 because this is 11 and 10 and 21, negative 21. So with this minus, it becomes positive 21. Positive 21. Negative 4i, negative 4j, and plus 7k. Now, so I combine these results and these results. So when you look at this, multiply this will be 84, negative 84i. And there is negative 44i, negative 44i, negative 84i. So added together gives you negative 128i. I do for the others. And when I did for the others, this is what I got. This is what I got when I did for the others. So you can follow this working. It's very easy. And that is how you get the scalar triple product and the vector triple product. The scalar triple product and the vector triple product. That's how we do that. So the other question was left for you as exercise.